So now we'll go to the difference between machine learning and deep learning, because that's where you'll understand better in terms of how and when this kind of things to be used, and what is the data that we're talking about, right? So as you can see on the top, right? So let me just yeah, as you can see on the top, right? So so let's just take a example of IPL data. Okay, so whenever IPL is going on, whenever matches are going on, we kind of predict something like we kind of predict the winning probability of, let's say, a team, or we kind of predict how much a team will score for particular match, how much that particular player will score, etc., etc. Right? So if you look at it, the table which is on the top, this is what we call a structured data. Okay, it's nicely structured, and you have specific information for all such a records, right? And this is a structured data. Okay, and when you have an application like you want to, let's say, tag Rohit Sharma. So in this below data, there are three photos of Rohit Sharma with different people, and you want to tag, let's say, Rohit Sharma, right? And uh, this data is called unstructured data. I'll tell you why, how it is. So structured data meaning your data is in a way that you have all sorts of features. Okay, so if you see here, RCB versus KKR, so it has this kind of feature. For example, inning, batsman, which batsman is playing, how much of run they've scored, what what over it is, which bowler it is, how many extra runs, total runs, etc. Right? And how many, like which team is going to get going to win this, let's say, match, right? So each such a match, like for example, let's say this is one of our match, right? And each such a match has a this kind of features. Okay, when you have this kind of features, when the data is structured in this way, which is more of a readable, you can definitely change, alter something, right? And this is what we call a structured data. Okay, and this is the data that you give it to machine learning model, and it will, there will be definitely labels meaning you are telling a machine to uh, you are basically directing machines or algorithms to predict something. Okay, so for example, RCB versus KKR, in that RCB won. Next time RCB versus KKR, RCB won again, right? So whenever you're trying to predict third time, because it was kind of winning, RCB winning every time against KKR for whatever reason, you most likely to predict RCB again as a winning team, right? So basically in the past you have given that kind of data. So this kind, based on all these parameters, all these fields, you're going to train the machine learning models, and that's where machine learning models will learn, and then it will try to predict next time when the same thing occurs. Okay, so this is your applications with respect to machine learning. Okay, now in the bottom, when you have application like you want to tag, let's say, Rohit Sharma, or let's say you want to tag, let's say, team's name, based on the jersey that you can see on the image, right? So here you can't really derive too much features, okay, because this you can get any image in any form. Okay, even you can even you can have a video in place of image, right? So it's really hard to get a features out of it. Features are it's like, for us it's easy to view, easy to watch, but for a computer to learn this thing, it will be really hard, right? So when the data is like this, okay, this is what we call unstructured data. Okay, also if we talk about text, right? So whenever we have a lot of tweets on IPL, okay, so getting a features out of the tweets, it will be difficult, because there can be anything people talking about in IPL, right? And they will be not set, won't be any set features for like this, which we are showing in the table, right? So that's where, when the data is complex, which is like image, or let's say text, voice, video, right? That's where, when the data is complex or unstructured, which is difficult to get a feature out of it, and because of the complexity and all, we use deep learning to teach such a applications, to learn from this application, right? So that's where we have a clear difference, that whenever you have a proper structured data, or let's say in case of semi-structured data, uh, are you going to use machine learning? Because machine learning, machine learning don't really do feature engineering by themselves. Okay, for example, if you just give minimum data, or let's say uh, partial data, learning models will not be able to figure out, the new kind of parameters or features, right? So that's where machine learning models are not really performing great. And whenever you can't really do anything about features, which is in the image kind of data, that's why you use deep learning kind of tools, right? So that is a clear difference between machine learning and deep learning, right? So deep learning is a part of machine learning, right? And deep learning is more of a based on our neuron structure. We have it's like we have a lot of neurons, and every neuron will perform some sort of a task, and collectively it will perform a larger task, right? So if you go into deep learning, we'll definitely can understand this, but on a high level, there's like this difference, right? So uh, uh, the so in deep learning, right, when we talked about there are four types of primary data which you can use to to perform any deep learning based task, right? Which is text, audio or voice, video and image, right? So definitely you can give this kind of data to the deep learning also, but it needs a lot of data, because deep learnings are models are data hungry, right? So sometimes because you do not have a lot of data, and you can't really fake data, you can't really augment data, right? So because of that limitation, you definitely have to prefer machine learning. And whenever you have this kind of data, which is image, you can definitely have a lot of variety of image, right? I can just flip this image and I can get a new image of the same thing, right? So I can generate a lot of, let's say, modified data, augmented data, to at least make deep learning models satisfying, right? So that way deep learning or machine learning is being used, right? So so the reason I'm talking about is because whenever we go further, we'll look at all these applications where this machine learning or deep learning is being used.